Hi folks, we are going to start talking about rotational kinematics and rotational dynamics. Now, everything that we have done so far in this class, we are going to do again, but we're going to do it in a circle. Rotational motion, for every linear thing, there is a rotational analog or rotational version of it. So we're going to start talking about rotational kinematics. Kinematics, if you remember, is a description of how things move. But everything we've done has been descriptions of how things move in a straight line. Acceleration, velocity, displacement, all of those in one dimension or another dimension. But we're going to talk about rotational kinematics. How many degrees or radians does an object move towards or through? What is the velocity in a circle? There are so many things that spin, everything from a fan blade to parts of a motor or an engine, or we can talk about the Earth going around the sun. All of these are examples of rotational motion. And if we're going to look at time, acceleration, velocity, and displacement in a rotational framework. Rotational motion also includes rotational dynamics. Remember, dynamics is why things move, and that involves forces of friction. The tires push on the earth, and the earth pushes back on the car, which helps it accelerate. Now, again, everything we've done has been in horizontal directions, vertical directions, but now we're going to start talking about how do you make something begin to rotate or stop rotating. This young fellow is pushing with a force perpendicular to a rotational axis, and that happens to be a torque. And torques start objects rotating, and a torque must be applied to change the motion of an object. So we're going to talk about that. Momentum. Momentum is that mass times velocity. And again, we've used that to talk about linear motion in one dimension or another. But there's such a thing as angular momentum. Angular momentum is momentum an object has because of its spinning. One of the things when I was a little kid, I loved watching the ice skaters on TV. And I always thought it was just magical that they could start out with their arms way out to the side, and then they just pull their arms in tight, and they go from having a slow angular velocity to a really, really fast angular velocity. All of that is covered when we start talking about angular momentum. Momentum is conserved as they move their mass from being far away from their body to being close to their body, and that causes that change in velocity. Energy. All of our energy equations, kinetic energy, potential energy, all of those have involved height, they have involved velocity, but there are a whole bunch of things that rotate and spin, and due to their spinning motion, they have energy. Circular saw is one of the most dramatic examples because this spinning object has so much energy that it can just rip pieces of wood apart. If you've ever gotten, your finger snipped by a fan blade, well, I did once when I was a little kid, and it hurt like stink. That is because these blades have lots and lots of energy, and they can impart that energy to other objects. As we go through our discussion, we are only going to be talking about solid or rigid objects as we refer to rotational kinematics and dynamics. That means we're going to stick to solid things like Ferris wheels and little carousels on playgrounds and circular saws. We are not going to talk about fluids. We are not going to talk about rotating gases. We're not going to talk about rotating liquids. And the reason is because these get very complex. And to just give you sort of an idea of how complicated they can be, think about something as simple as stirring your coffee. If you stir a cup of coffee, you are going to have friction between one molecule and the particles next to it. The particles on the outside edge are going to have friction with the wall. The particles near the center are going to have friction with the spoon. As this picture kind of illustrated before I got crazy drawing all over it, there is kind of a vortex that's created where part of it goes down and part of it is further up. So you've got motion up and down inside of that fluid. It is very complicated motion, and we mathematically are just not going there. All right, that will do for this time, and we're going to come back and start with rotational kinetics.